So what we introduced the last day was that if I have a circle, any circle, okay, and if I have a circle that looks like this, and basically I pick 2 points to represent an arc. These 2 black points represent an arc. Therefore, this here is known as the minor arc. Is everybody cool with that?
Yeah.
Now, if I draw an angle to the centre of the circle, like so, if I choose any other point on the circle, it can be on the top, like this point here, and what will automatically happen is that the angle at the top angle will be half the value of the bottom angle. So example is, if that's 100, that will be 50. Are you okay with that?
Yeah.
Now, if I move this point around and I make it look a bit more awkward, so sorry, just move this point here. If I move it all the way over here, and now I have to move my 2 legs like so, it still remains the same. This is still 50. And even if I go a bit further with it, that point, so I know it gets a bit more awkward looking. If I go a bit further like that even, okay, it's still the same deal. It's still going to be 50 degrees. Okay, even though it doesn't look like it. And that angle there, still 50. Everybody cool with that?
Wait, sir, that not be 50 because it goes to it doesn't go to the same point the arc.
Oh, sorry. I see. Thank you, Charlie. That's 50. Once it's standing on the same arc. Is that cool, you guys? Now, the next rule that I want everybody to know is this.
What happened now? Like it was like underneath it, like.
Yeah. Oh, you want me to go underneath? Okay. If I go underneath like this, you then transfer from the you transfer from standing on the. You have to be above the minor arc. Do you see the way the angle's above the minor arc?
Yeah.
All right. Now, if I did a major arc, the major arc is in yellow. Is everybody happy? The major arc is in yellow.
Yeah.
Okay. And what will happen here is if I get this point, I'll just rub it out. If I get this point and move it over the other side of the circle, like so. Alright? And now I join my legs down here. Is that what you're talking about, Connor?
Yeah.
Just something like that?
Yeah.
Okay. Yeah, I think that's clearly an obtuse angle.
Yeah.
And 50 degrees ain't gonna cut it, is it? So that for me means it changes from standing on the minor arc to standing on the major arc when it goes underneath. So the major arc is what? 260, and then half of 260?
130.
Exactly.
Yeah.
Under versus over. Is that okay?
Yeah.
Now, the other point we're going to hit here, guys, is just some more introductions, okay? What we're going to do is any 2 points standing on the same arc. So, for example, for argument's sake, ignore the centre of the circle, it's not necessary in this question. For argument's sake, I say that's 40. Okay? Can anybody tell me what is the next angle? The red angle here.
40.
Why is it 40? Yeah, it's standing on the same arc. It's standing on the minor green arc, isn't it? And both points are on the circle. Now I'm going to try something else here. Tell me if it's the same or not. Ready? Is that also 40 degrees?
Absolutely not.
Why not, Isaac?
Because it's not standing on the same arc.
It is standing on the same arc.
No, it's like the top point isn't.
Top point isn't actually on the circle.
Yeah.
So it cannot be 40 degrees. Is that cool, you guys? Now we have a look. That's 40 because it's half of 80.
B's 40.
And B is also 40 because it's standing on the same arc. Here's your minor arc and everything's standing on that minor green arc. Is that cool? They look really complicated, but then after a while they're not so bad. Alright. Isosceles triangle Y. Both radiuses, are they?
Yeah.
And then this is 100 because all triangles have to add up to 180. And a half of 100. And you're done. We cool? Yes. Yeah, 10. 10 it is. Just give me a sec. Yeah? Alright. I was shocked at how many people don't actually do that before doing the test. So there you go. Alright guys. Lads. Okay. Now, lads, what we can do here is we can relate this angle here to this angle here. Any ideas?
That 110 double is
220. So we got 220 here. And what's 220 from 360? And what's half of 140?
70.
There you go. It was the major arc, wasn't it? Underneath the major arc, so you had to use the major arc that time. Alright. What are we on? 12, yeah? We've done 12 already, did we? So we've done 9, 12, 10. And now we're on to 15. 15, 18, 21, 24, 30. So I'm just taking down the numbers I'm doing in this one, right? Alright guys, here's one to the centre, isn't it? What's that? 108. What's half of 108? Why is that 54? It's standing on the same arc, and the angle at the centre of the circle is twice the amount of it at the point on the circle standing on the same arc. Q. Okay. Isosceles triangle. So R plus R, the angle will be R on both sides, so it's R plus 108 equals 180.
2 hours then.
36, yeah.
Is that okay? Move on? Right. Now, I think we're going to be alright with this one as well. Alright? 360 take away 240? 120. Half of 240? Okay. 4 angles in a 4-sided object have to add up to what? So 120 plus 120 plus 50 plus S equals 360, and Isaac says S equals 70 degrees. Cool. Yeah. 21. Now, new learning here, there's something that's called a cyclic quadrilateral. Is that okay? And there's a special rule for a cyclic quadrilateral. So I'll give you an example, alright? So, if I design a 4-sided object, okay? Like so. Okay? Now I'm trying to think. Perfect. Like this. Everybody cool with that?
Yeah.
Now, would everybody agree? Sorry, I have an idea. Sorry, I'm gonna almost turn it into a parallelogram. Not quite a parallelogram, but almost. Alright. Now, would everybody agree that this angle here plus this angle here?
180.
No. They're not equal either, because it's not a parallelogram. It looks like a parallelogram, but it's not.
But don't they add to 180?
No. Not yet. Okay. So, in a quadrilateral, it's not guaranteed that the 2 blue angles will add to 180. It's not guaranteed that these 2 blue angles are equal to each other, because I stated that this is not a parallelogram. Nor will the green angle equal the red angle. Nor will the green angle... Put your hand down. I haven't finished my point yet. Okay, thank you. Alright. Now, next thing I'm going to do is I'm going to draw a circle. Any circle I want. Okay? Those are regular quadrilaterals, okay? Now we're going to do what's called a cyclic quadrilateral, where I pick any 4 points on a circle, like so. Doesn't matter how I pick them, okay? And I draw them into each other like so. Okay? Now, if you were to get out a protractor and measure each one, okay? So if I was to measure this one here, what are we saying, roughly just under 70 degrees? That be okay with you? Okay. Now I'm going to go, so user friendly, but I'm going to go up to the top right one now. And what do you reckon for this one then? I have it lined up nearly at 90. What do you reckon? Actually no, I can't. I have to go higher here. So I have to line it up like this. 111 degrees. So do you notice that those two angles added together actually equal 180? So it's opposite angles in a cyclic quadrilateral will equal 180. That's essentially what I'm trying to get at. You can measure them if you want, and that's what will happen. Black angle plus red angle is, anybody? And then green angle plus, I don't know, purple angle? 180. Now you may pull up your hand and ask, just to recap what we're saying is that the black angle plus the red angle is 180 and the green angle plus the purple angle is 180. They're not equal to each other, but they do add up to 180. Alright, so let's try this out. We know angle Y is what? 29. 180 take away 29 twice. 180 take away 58. Anybody?
122.
22. Now, opposite angles in a cyclic quadrilateral it's called. Cyclic because all 4 points are on a circle, quadrilateral because it's a quadrilateral. What is this the red angle plus the blue angle equals? So what's the blue angle? Oh, lads, stop for a second. That's not 22.
It's 122. Yeah, it's 122.
It's 180 take away 22, which is 158. That's clearly an obtuse angle, isn't it? So,
It's 122.
Shh. Sorry lads, it's 180 minus 58, which is 122, my bad. It's clearly an obtuse angle, right? So, what I'm saying is this red angle plus this green angle is 180. So what's the other one then? 58. Thank you very much. Sorry about the mix up. Alright, that's 58. Now what else can we do here? Yeah, I think we can add up all the angles. So what you do is, they all have to add up to 360, don't they? 122 plus 29 plus 47 plus 58 plus 29 and plus and plus W equals 360. A quicker way is to do the opposite angles in the cyclic quadrilateral. So what you just basically attach is 47 and 29, shush, 47 and 29 plus 29 plus W is 180. Is that okay? Oh God, how did I not see that? Alright, and now a third way of doing it, which is even quicker, is 180 take away 47 take away, and what you get?
I got 75.
75? Alright. 3 different ways. That was the quickest. One of them was much longer, but they all get you to the same place, don't they? Happy days.
Can you do 22?
Yeah, Charlie actually was going to ask me about that now as well. 22, Charlie? Let's begin. Question 27. Okay. Focus, please. No noise. No tapping either. It's distracting. Okay. Now, next thing is, when you see a point like this, where it hits the circle once, it's a tangent. Straight away, you know that this red angle is 90. And you obviously know that this green angle is also 90. Now, I don't know if that's going to necessarily give me any additional information that I want. But what I can next say is that this is an isosceles triangle. Would you agree with that?
Yeah.
So that's 25. Happy enough? Now, if that's 25, we can get that as, yeah, that is 65, but I don't think, we have it now. Why don't I go for this black angle here? 180 take away 25, take away 25? 130, okay. Now we have it. 25. The tangent was almost a distraction. I haven't used it yet, have I? No. And then 130 take away from 180? 50, because it's a straight angle. I know that this is an isosceles triangle. Why? Both radiuses. So 180 take away 50? 130. And x has to be the same. So divided by 2? 65. Both of the x's are 65s, okay? Now I think I'm going to use the tangent part now. Alright, finally, because this is a tangent that's 90 degrees, which makes this small red angle 25. This green angle here has to add up to 180. So what is it? 115. Angle Y is 180, take away 115, take away 25, which is 40. You cool with that? Charlie, question.
Could you also do 108?
Now, alright lads, here's what we do. I draw a linking line in between the two of them. I've now essentially made an isosceles triangle. So what angle is this? 20 degrees. Would you be happy with that?
Yeah.
Now, we know that the top angle, the black angle, is half the red angle. So what's the black angle? Half of 36 degrees?
169.
Just 69 degrees, okay? 69 degrees, take away 20? 49. And because it's an isosceles triangle, x must be 49. Alright. Now, so what we've done today, in today's class, we did 6, 9, 12, 10, 15, 18, 21, 27, 30. I want you guys to do the following. You had up to 15 the last day, didn't you? 16, 17, 19, 20. We'll put 22 in there. 24, 26, 28. How does it go up? 38. Alright, that's for your homework. And what page is this on?
464, 465, 466.
464, 465 and 466. And that's your homework, isn't it? Okay. Okay guys, you start that now for me, that'd be awesome.